Welcome back to my YouTube channel. This is Mr. Sam once again, and this is chain rule. We are discussing chain rule in differential calculus. This video is the second video in a series of videos for differential calculus. So if you have not watched the first one, you can do well to go and watch it before coming back to watch this video. So in this video, we are going to be discussing chain rule. We'll take some examples, and then as usual, I'll give you some exercises at the end of the video so you can practice what you have learned in the video. So, why the name chain rule? If you have, say for example, y equals x plus 2 all squared, we know that this means you expand the bracket like this into, and if you have it, that will be x equals y equals x squared plus 4x plus 4. You can find the y dx of this very easily. If it is kind power 3, then that means you have 3 brackets. If you want to start opening them one by one, it gets harder, and if it's power 4, power 5, power 7, something like this, it will be very difficult. So, because the brackets you keep opening like that, like a chain, that brought about the name chain rule. So, how do you differentiate functions like this, where it is going to open up to give you a chain? Another name for chain rule is function of a function, and you understand why in a bit. So, this is how we explain chain rule. We say if y is a function of u, and u itself is a function of x, then we can say dy dx is equal to dy du times du dx. Now, it might look new to you and be like, all this function. But will you understand? Let's go. If you enter examples now, you will see that it's very easy for you to understand. So I'm going to take a few examples now, and then I'll apply this rule. You will see how easy it is. In fact, it's very simple. So let's go. So these are the questions that we have for the examples. Let's look at this question and see how we can apply this rule to solve them, and at the end you should be able to solve your own very easily. So solution. Example number 1, we have y equals 2x plus 3 raised to power 4. Remember we say y is a function of u and u is a function of x. Well, in this case, y is a function of x. So we have to make y a function of u, so u will be a function of x. How do we do that? You see this function that is here, 2x plus 3. Whatever is here that is carrying the power, we make it u. So we can first start by saying let u be equal to 2x plus 3. So u is this. I tell my students, immediately you've done this, quickly differentiate this. And to differentiate means to find du dx, and if you differentiate 2x to give you 2, this one is 0. So that is du dx in the formula. Can you see that? Now, if u is this, we are going to substitute u back here and say y will be equal to, since u is 2x plus 3, so that will be u raised to power 4. And now that we've done this, we're also going to differentiate. So differentiating this will be dy du. The coefficient here is 1 times 4, that is 4u raised to power 4 minus 1, 3. So that is the dy du. So you see that very easy. So now how do we find dy dx? Just say dy dx is equal to dy du times du dx. dy du is 4u cubed times du dx is 2. We multiply 4 times 2, that is 8u raised to power 3. So in our final answer, we can substitute back the value of u. U is what? 2x plus 3. That will be 8 into brackets 2x plus 3 raised to power 3. That is the answer to that question. So this is the y dx for this. Now number 2, we have y equals 2x squared minus 6 raised to power 5. So I'm going to follow the same rule now. So we say let u be equal to 2x squared minus 6. So if u is equal to 2x squared minus 6, what we'll find next will be du dx. Now we differentiate this. This one will give us 0. We differentiate 2x squared to give you 4x. So now, if u is 2x plus 6, then y is equal to u raised to power 5. U raised to power 5. So now we'll find the y du. And this will give us 5u raised to power 4. So we found the y du, we found the u dx. Next thing is dy dx. The y dx will be dy du times du dx. At this junction, let me show you something. If you notice this formula, normally if you are doing something like in maths, if you cut du, all you have will be dy over dx, which is the same thing here. It shows that the formula is a very correct one. So now let's substitute. Y du is 5u raised to power 4 times u dx is 4x. 5 times 4x is 20x. So we have 20x, then u raised to power 4. That is 20x. U is 2x squared minus 6, then raised to power 4. That is the final answer to that question. Now let's go to number 3. Number 3, we have y equals 1 over 2x raised to power 4 minus 6x. The 1 over here from our knowledge of indices, we know this means everything here is power minus 1. So we have 2x raised to power 4 minus 6x raised to power minus 1. So this is our function. Let's find dy dx. So first of all, we'll say let this expression be u. So let u be equal to 2x raised to power 4 minus 6x. So we'll find du dx. Differentiate 2x raised to power 4. That is 8x raised to power 3. Minus differentiate 6x, and that will give us 6. That is dx. Now, if u is this, then y will be u raised to power minus 1. U raised to power minus 1. So here now we find dy du. The coefficient is 1. That is minus 1. That is minus 1u raised to power minus 1 minus 1 minus 2. That is basically minus 1 times the minus here means 1 over, then u raised to power 2. So we have minus 1 over u raised to power 2. That is basically dy du. So what is dy dx? Dy dx will be equal to dy du times du dx. Dy du is minus 1 over u raised to power 3. Du dx is 8x cubed minus 6. To finish the final answer, let me quickly clean this space. So that will give us minus, since we are saying minus 1 times this, I can use a bracket there, so that is minus 1 times 8x cubed minus 6 all over u raised to power 3. So if you expand this with minus, you have minus 8x cubed minus times 6 plus 6 all over u is 2x raised to power 4 minus 6x. So we have 2x raised to power 4 minus 6x. Everything is going to be kind power 3. And this is our final answer for number 3. I hope you are getting it because I'm trying to explain them step by step. So if you think I'm rushing, please try and just go back again and watch. Number 4, we have y equals square root of 2x plus 1. Now, the square root can be expressed as the power of half from our knowledge of indices. So this is in this form, the form that we need. So now we'll say let 2x plus 1 be equal to u. Okay, so let me write that. U equals 2x plus 1. So we'll find du dx. If you differentiate this to give you 2, 1 is 0. So now that means y will be equal to u raised to power 1 over 2. So we find dy du now. What would that be? 1 times half u raised to power half minus 1 minus half. So basically what we have here is 1 over 2 times the minus 1 over u raised to power half, which is square root of u. So 1 times 1 over 2 roots u. That is dy du. Now, dy dx. That is dy du times du dx. Dy du is 1 over 2 root u times du dx is 2. So they are multiplying, they can cancel out 2. You can say 2 cancels 2. And our answer is 1 over the square root of u. So the final answer, we bring back u as 1 over square root of what is u? 2x plus 1. 2x plus 1. That is our answer. So we differentiate y equals square root of this is 40. Okay. So those are the examples that we have to explain chain rule. By now you should have seen that chain rule is very simple already. So if you have had problems with it before, I hope this video has explained it better for you. So I'll be giving some exercises now as usual that you practice with, and then I'll see you in the next video. So these are the exercises for this video. Try and solve them and really try to get the correct answers. If you didn't understand some parts, you can do well to watch the video again and then try them again. So with your knowledge of indices and the rule of differentiation, you should be able to solve these questions. If you are new to my YouTube channel, do well to subscribe, as you will be notified quickly when I'm sharing new videos or new content like this. So watch out for the next video where I'll be going further into another rule in differential calculus. Thank you for watching.